Hi everyone, it's Mrs McInnes here. Welcome to lesson 9 of our trig topic. So this is really the final part to the work that we've been doing on sine rule and cosine rule, and we're going to be adding on to what we've already been learning by including some three-figure bearings in the questions that we are looking at. So three-figure bearings are very, very simple, but it's something that I think you'll need a reminder of how to read them and how to write them. So to measure a three-figure bearing, you always start from north and you measure the angle going round clockwise. So if you look at the diagram on the left-hand side here, we have X, Y, and Z as three different points. From each point, there is a north line being drawn exactly vertically upwards, okay? So that's your north line. And then you would be measuring from that line round clockwise until you hit wherever the line is that you're looking at. So for example, if we look at X and Z, okay, the notes here say that the bearing of X from Z is 311. So from Z, whatever you're measuring from is the point that you are looking at, okay? So if you're measuring from Z, you would be starting at Z, starting at north, measuring round clockwise till you hit the line that goes out towards X. So that angle there has been measured as 311. If you look at the X and the Y, okay, the bearing of Y from X is 75. So from X, from north round till we get to the line for Y would be 75. If it doesn't have three numbers, the angle that you measure, you have to add a 0 in to make it three numbers. So if it's anything less than 100, you add a 0 on the front. So 75 degrees would be 075 as a three-figure bearing. Okay, so there are a couple more examples in this box just over on the left where you have A, B and C. So you can see there the little red shaded angle, that is the bearing of B from A. So from A, measuring from the north line round till we hit the line for B. So B from A is that red one. In the middle, the blue angle would be the bearing of A from B. Okay, so A from B. So if you're at B, starting at north, measuring round till you hit the line for A, that blue angle is the bearing of A from B. And then at C, you have there the green angle is the bearing of B from C. So looking at C, north line, right round till you hit the line for B, that green angle gives you the bearing of B from C. Okay. Now this box at the bottom is very useful for this topic. You can use Z angles and F angles when you're looking at bearings. Some of your more basic angle work will be useful when you're doing bearings questions to fill in missing angles. But a really useful little tip is this at the bottom here, where you have two angles inside two north lines. They both make up 180. So the A and the B would make 180, and then similarly on the other side, that X and the Y, those two would make up 180 as well. That is all to do with extending out straight lines. So for example, if I draw just one of those out, I will show you what I mean here. So if we had our north line here and our second north line here, if we have an angle in the corner just here, if we were to extend that line straight out, okay, that red angle would also be the same just up here. So that means that the angle on the other kind of inside bit, this blue bit, that's going to be the supplement of the red angle. So whatever makes it up to 180. So say, for example, that red angle was 60. That means up here that would be 60 as well. And then knowing that it's a straight line, that makes the one on the inside 120. So without having to draw this extra bit on the outside, you could just use your rule, knowing that they make 180, to fill in one if you know the other. Okay. So how are we going to apply this to our trig questions? Well, we'll use the bearings rules that we've looked at here to fill in some of our angles. So example 13 in your notes is as follows. We have here that a ship is 1.9 kilometres from a lighthouse on a bearing of 065. So that is the point S is 1.9 kilometres from the point L for the lighthouse, S for ship, L for lighthouse, and the bearing of 065 tells you that that little angle just in the corner you can see there is 65, so S from L is 65, so measuring from the north line at L round till we hit the line that goes out for S is 65 degrees. You're then also told that a jet ski is 0.6 kilometres from the lighthouse on a bearing of 100 degrees. So from L out to J is 0.6 kilometres, and again it's from the lighthouse, so going back to that same north line, measuring right round till we hit the line for J, we get 100 degrees, okay? So that is that big angle there is 100. So we're being asked to calculate the distance between the ship and the jet ski. So let's label our triangle with our small case letters first of all. So we have small s, small l and small j. And we're being asked for the distance between the ship and the jet ski. So between s and j. So we're being asked for that side there, which is L. So if we're finding a side, if we're going to use sine rule, we would need two angles filled in. Equally, if we were going to use cosine rule, we would need one angle filled in. There are no angles inside that triangle. However, you do know that that large angle of 100 overlaps with the smaller angle of 65. So what you can do is you can fill in this angle in the corner here by working out the difference between the two. So 100 minus that 65. So if I just write that over here, so 100 minus 65 gives you 35 degrees. So that angle inside there would be 35 degrees. So that's the only angle that you can fill in. We can't fill in the other two angles in that diagram. So we won't be able to use sine rule because we would need two angles, but we can use cosine rule because we have two sides with the angle in between. So for side L, it's going to be j squared plus s squared minus 2js cos L. So we've got 1.9 squared plus 0.6 squared minus 2 times 1.9 times 0.6 times cos 35. That gives us an answer of 2.102 and so on. So for L, we would square root that last answer. So that gives us 1.45 kilometres. So I'm just going to write distance just to answer the question. So distance equals 1.45 kilometres. Okay, part B, we're now finding a bearing. So we're asked for the bearing of the jet ski from the ship. So wherever you're measuring your bearing from is where you start measuring your north line round till you hit the line for the other letter. So the jet ski from the ship. So we're going to start up at the ship here at S, measuring right round till we get to that line for the jet ski. Okay. So here, this will be new territory for us. We haven't really done anything like this yet, but it is just all angles work. So we need to think, how can we find just that green angle, that bearing? How can we find that? Well, think about what we know. We could fill in the angle inside the triangle. So we could fill in this little red angle here. And we can actually also fill in this blue angle up here because that is inside the north line and would go along with that 65. So the rule I showed you was that those two angles inside those two north lines make 180. So 180 minus 65 is 115. So that blue angle is 115. So the blue, the red and the green together make a full circle, which is 360. So to find the green angle, which is what we need for the bearing, we know the blue angle. If we just find that red angle, we can subtract the 115 plus the red angle away from 360, and that will give us the bearing. So really what we're looking for is this angle at S. So let's see if we have what we need to do sine rule first of all. So if we're going to do sine rule, we would need two pairs that go together. So for the angle at S, we have the side S. So that is okay, we need that. If we were going to use the 1.9 kilometers, we would need the angle straight across, which we don't have. Okay, equally, if we were going to use the 35 degrees, we would need the length on this side at L. So we could do sine rule with that. We would need that length there, and we've just done that. That's 1.45 kilometers. So we now know we have what we need for sine rule. So let's set up our sine rule calculation. So it's letter L and letter S that we're using. So it will be S over sine S equals L over sine L. So side S is 0.6. So 0.6, I'm just going to slide the page up a little bit. So 0.6 over sine S. We don't have S, that's the angle we're trying to find, so that's fine. We can leave that as an S. And then side L is 1.45 over sine 35. So we'll cross multiply now and find that angle S. So starting with the unknown value when you do your cross multiply. So sine S times 1.45 equals, and then times the other side, 0.6 times sine 35. So then we would divide by 1.45. So sine S equals 0.6 times sine 35 divided by 1.45. So on your calculator, we are going to get 0.2373 and so on. So to find S, we would need to do the inverse sine function to our last answer. So I'm going to round this to the nearest whole degree. So it comes up 13.729. So I'm going to go for 14 degrees. So if we just quickly look back at the original picture, we are trying to find that bearing, which is that large green angle on the outside. So we know the blue part is 115. The red part we've just worked out is 14. So we would now need to work out the bearing. So 360 minus 115 and minus that 14. So that leaves us 231 degrees. So we would just answer the question. So bearing equals 231 degrees. Okay, there is only one of these questions in the printed notes. So what I felt would be useful is to add in a couple of extra examples for you, because bearings is the kind of thing, I think once you've seen a few of them and learned some of the little tips and tricks, they are easier to try when you're trying the questions yourself. So I've added in 2 more questions to your notes. So if you can make a note of these, that would be brilliant. So Here we have this question where we have a ship leaving port on a bearing of 73 degrees and sails 63 kilometres. The ship then changes course and sails a further 60 kilometres on a bearing of 110 where it anchors. When it anchors, it is 95 kilometres from the port. Calculate the bearing of the ship from the port at this point. So there's a lot of information there, and what I would tell you to do first is to apply everything you can to your diagram. So first of all, let's read through it. We have a ship leaves port on a bearing of 73 degrees and sails 63 kilometres. So this is the port just on the left hand side, and it's sailing 63 kilometres on a bearing of 73. So that tells you that that angle in there is 73. From the north line round to the line that you would hit is 73. Then when this ship has sailed that 63 kilometres, it changes course and does a further 60 kilometres on a bearing of 110. So it's turning direction just at that second point in the triangle, and the bearing there is now 110 degrees. When the ship then anchors, so it's just going to anchor just at this point down here, it is 95 kilometres away from the port. Calculate the bearing of the ship from the port at this point. So at this point, okay, so if we add in a north line, we want to know the bearing of the ship from the port. So from the port, so that would be this large angle here. Okay, every point in your triangle should have a north line in it, just as a matter of course to draw that in. So that's why I've added that one in at the bottom there. So that large green angle, you can see we already know part of it is 73, but we are missing part of it. So if we work out this red part here, we can add the two together for the full bearing. So if we first of all label the triangle, so let's just go for A, B and C, and then small a, small b, small c. So really we're looking for the angle at A. So if we were going to use sine rule, we would need another angle, and we don't have that. We have no angles at all. We have all three sides, so that would be your cosine rule. Okay, and I'd be hoping you would be recognising at this point that all three sides is cosine rule. So for cos A, it's b squared plus c squared minus a squared over 2bc. So we would have here 95 squared plus 63 squared minus 60 squared over 2 times 95 times 63. So as an answer for this, we are going to get, if I just slide this page up a little bit further, we get 0.7847 ... So for A, we would do inverse cos of that last answer, and we get 38 degrees there. So your bearing, we need to remember to answer the full question. We now know that that red section in there is 38, so we just need to add 73 and 38 together, so your full bearing is 111 degrees. Okay, I've added in one final example, and I've tried to choose something kind of as challenging as you could get for this type of question. So here we have a question without a diagram. All you would do in this situation is you would draw your own diagram. So we're told here that two ships leave Liverpool at the same time. One of them travels northwest at an average speed of 10.5 kilometres per hour, and the other travels at an average speed of 14 kilometres per hour on a bearing of 280. How far apart are these two ships after 2 hours? So there's a lot of information again in this question. So if we take this piece by piece and work through, we can draw ourselves a visual diagram to help. So we're told that the two ships are leaving Liverpool at the same time. So we're going to have the same starting point for both of these ships. One of them is travelling northwest at a speed of 10.5 kilometres an hour. So that, first of all, is giving us the bearing for that first ship. So if you think of your compass points, so north, east, south and west. Northwest is exactly halfway up here. So if you were measuring all the way around, up to the west line would be 270. And then you're going halfway up the next section. So that next section would be a 90-degree section, but we're only going halfway up. So it's 270 plus another 45. So that would be 315 degrees as a bearing all the way around. Or you could measure it as just 45 in the opposite direction. Either way is fine. So let's pick a starting point. Okay, so let's go right in the middle of the page and we're going to draw a north line straight up the way. So the first ship is going northwest. So like I said, you could measure round clockwise or you could just measure backwards 45. So we could just go for backwards 45 to make that easier to draw. So let's just draw a line, doesn't really matter how long it is. So in this wee corner here, we have 45 degrees. And the length of this line we can work out. So we know that this ship is going 10.5 kilometres an hour for 2 hours. So we have that in the question. So 10.5 kilometres an hour for 2 hours. We're just doubling that up, which gives us 21 kilometres. From the same point, we're told that the other ship is travelling 14 kilometres an hour on a bearing of 280. So we're going to have to roughly draw where 280 is. So remember, 270 would be exactly across like that. So 280 will be just slightly above that. So something kind of like that would be fine. So we know that the big angle round to here is 280. And the length of this line this time is 14 kilometres an hour for 2 hours. So that line will be 28 kilometres long. We're asked for how far apart the two ships are. So you're asked for that distance between the two. Okay. So we now have a little bit wobbly, but we have a triangle drawn out and we can use this now to go through and work out our question. So we're being asked for the length of a side. So let's label the triangle. So let's just go for, we'll call the bottom bit here L for Liverpool. That's where they've both left. And then we'll just go for a B and a C. So small L, small b, small c. So we're being asked for a side. And if we were going to use our sine rule, we would need two angles inside that triangle filled in. Well, the only thing you can fill in is that angle just in here, this red bit. You can fill that in. You know the full circle is 360. We know the outer angle is 280 and that little piece on the inside is 45. So we can work out the angle that's missing. So 360 minus 280 and minus 45 means that that little sort of slice in the middle is 35 degrees. So we've got one angle, but we can't fill in any other angles. So we wouldn't be able to use sine rule. But we have two sides with the angle in between, so we can do cosine rule. So L squared equals B squared plus C squared minus 2BC cos L. And then we will fill in the values that we have. So I'm just going to slide the page up a little bit. So for B, we have 28, so 28 squared plus 21 squared minus 2 times 28 times 21 times cos 35. That gives us 261.677 and so on. And then we would square root. So that gives us a length of 16.2 kilometres. So I would answer the question at the end. So the ships are 16.2 kilometres apart. Okay, so I've tried to give you a variety of questions here. This is the type of thing that we will spend a couple of periods at least on, just to practice, and the bearings sort of part of this will be a little bit unfamiliar to you. So we will spend some time practicing. So for today, I know this video is quite long, so I've only chosen 4 questions that I would like you to do. So page 35, question 11 and 12, and page 41, question 3 and 8. Please don't worry if you don't get all of that done today. I doubt that a lot of people would get all of that done today. Just do what you can do today, and I will give you the next period as well to finish off these questions, and I'll probably post some extra questions for you to work on as well. Okay, so make sure you mark your work from the back of the booklet, and please come on the Teams page and ask for help if you need help with any of these questions at all. Okay, thanks guys for listening, and I'll speak to you soon. Bye.